Greeting all viewers at home. I'm Marua Mamabolo from Ehlanzeni TVET College at Nelspruit campus under the program of Electrical Infrastructure Constructions. The subject is Electrical Principle and Practice. The level is level 4. The topic is going to be the topic of fundamentals of electricity. So this topic is the continuation of the topic that we did for the previous. So whereby previously we've been started with the combination of the Ohm's law and the Kirchhoffs law. So now today it's going to be only the Kirchhoffs law without the Ohm's law. Why are we going to say that we're going to use only the Kirchhoffs law? The reason is, for the previous one, for the second diagram that we've been given, it was having only one applied voltage. So if we started to be given more than one applied voltage, it will be so difficult to use an Ohm's law. It's whereby we're going to use what? We're going to use a Kirchhoffs law. So let's remind each other on terms of when we're talking about a Kirchhoffs law, what are we talking about? So the Kirchhoffs law, it do have the two basic law, whereby the first law is what? Is the current law, and the second law is what? Is the voltage law. So let's go through to the current law. The current law states that the sum of the current entering a junction is equal to the sum of the current leaving a junction. So now, for the voltage law, it states that the voltage applied to the closed circuit is equal to the sum of the voltage drop that circuit. So now, again, if you can try to look the part of our circuit diagram there, it has been labeled, whereby it has been labeled A, B, C, D, E, F, which is the part of the labeling there is our loop. So which is, on terms of making our calculations, we are going to use our loops. So what are we going to say about our loops? We can ask ourselves to say, what is a loop? A loop is any continuous path that leaves a point in one direction without leaving a second. So which means this it will be my path connection. This is going to be my path connection. So which is leaving from the supply because of the second. Mind you, the second is starting from where? From your applied voltage. So which is it will be from A, B, E, F, back to A. It didn't leave what? This loop. So now, if you can check again, we can say that, again I can say that I'm having another loop, which is what? B, C, D, E. We can ask ourselves to say that, why we are not saying F, E, B, A, back to F? The reason is, we are talking about the conversion of the current. The conversion of the current is flowing from positive to negative on terms of part of our terminals there. This is the conversion of the current. That is the reason we've been started where? At the part of A, because of it's our positive side, which is A, B, E, F. Even on this part of another loop there, I'm saying B, C, D, E. But we can ask ourselves to say that, how many loops do we have there? So the loop that we are having there is the loop number 1. Still again, can choose the loop of B, C, D, E. Can still call it this as what? As loop number 2. And again, if you check, still again, A, C, D, F, back to A. It can still be a loop number 3. So, but what is going to happen is, they're going to give us a directive to say that which loop are we supposed to consider when we're making the part of the calculations. So if the question has been asked without giving you a direction of the loop, please, students, make sure that you choose the loop that the current is flowing by the same directions. What I'm trying to say is, if you check A, B, and B, E, these two currents there, they are following by the same directions. So if I'm going to choose the current of what? If I'm going to choose what? If I'm going to choose the current that is opposing the directions, what is going to happen? Say B, E, D, C, B. I'm going to have a collision of what? Of the current of the I2 and I1 minus I2. Now it's going to be the collision. So if it's a collision, obviously, what is going to happen? It's going to force another current to do what? To change its direction. So to avoid that, because it's going to be more complicated, make sure that if you've been given a loop that you're supposed to select there, make sure that you do what? You select the current that is flowing by a same directions. So now, let's go through to the part of our question, how they can ask this question. They are going to strictly the part of the question. It's going to indicate to you to say that strictly use what? Use a Kirchhoffs law. Because of if they didn't indicate, obviously we are going to be what? We are going to be confused to say that are we going to use the Ohm's law or the Kirchhoffs law? So now, here is the part of the question saying apply a Kirchhoffs law by using the figure that we've been given there. And determine what mostly will determine there, it will be the part of the current. Even if they didn't stay to say which current. If they say determine the current, must be all the current that are entering through to your junctions. So I'm having what? I'm having I1, I'm having I2, I'm having I1 minus I2. So those are going to be what? It's going to be the current that we are going to calculate. So now, if you check, I'm having I1 and I2, which is the two variables. I'm having I1 and I2. I don't have all those values of I1 and I2, which means I'm having what? Two unknown values or two unknown variables. So now, to make things easier on our side, if we're working with the two unknown values, we are going to use a simultaneously. And if it's simultaneously, you will need to create your equations. So now, we have been given a directive on part of our loop there to say that which loop are we supposed to select there. So now, they are saying that the loop that we need to select there is what? Is a loop A, B, E, F, back to A. Say A, B, E, F, back to A. Another loop that they are saying that we need to select there, they say is a loop what? B, C, D, E, back to B. So which means we've been given the two loops that we're supposed to work on it. So now, what we are going to do there, we're going to say that we are going to consider by the loop that we've been given, which is the loop of what? Consider a loop A, B, E, F. And where we've been started, we need to end there, which is a loop what? Which is a node A there, which is A, B, E, F, back to A. So now, what is going to happen? In order to create our equation, as I said that we're going to work with the equation whereby it's going to be more than one equation to work with a simultaneously. So the equation, and you will say that on terms of the Ohm's law, we still remember, but for the previous we've been said the Ohm's law is what? Is a V is equals to I times R, whereby the V is going to be the applied voltage, and then the I times R is going to be what? The voltage drop across what? Across your circuit. Where are we having a voltage drop? Once that you have a component and a current starts to pass through to that component, obviously we are going to have what? We are going to have a voltage drop. So now, what is going to happen is the V there, it will be my supply there. I'll have 100 volts, which is that the 100 volt is coming from where? From a line of what? Of our A and B, because I'm starting from the positive there. So which is the 100, but still again in A and B, I'm having what? I'm having the I and the R, which is the I and R, it will be the part of our equation, which means we'll say that we're having what? We're having 0.5, which is our resistance there. And then the current, I will say that I'm having what? I'm having the I1. So now I'm having a point of what? A and B. So I'm supposed to go to what? To a point B and point E. So the point B and E, it has been contained with what? The I2 and the R2. So which is, I will say that I'm having what? I'm having what? I'm having, the R2 is having what? Is having a 0.5 again. And the current of that is what? Is the I2. But still again in B and E, what is happening is, I'm still having the voltage there. So which is, I'm still going to include that voltage because of that voltage is still on the same line with what? With my voltage drop, which is what? Which is a 36. So now, what is going to happen is, to make things easier on our side, let's try to group the like terms. So whereby the like terms, if you check, obviously going to be 136 because of 0.5 I1 and 0.5 I2 is not the like terms. Why did I say it's not the like terms? It's because of I'm having the difference variables there, which is I1 and I2. So now what is going to happen is, let me just group the like terms together. I will take the 36 to the other side. Obviously, it will do what? It will change a sign, which is, it will be what? It will be a 36. It will be minus 36, which is equals to 0.5 I1 plus 0.5 I2. So now, through to our loop, there is, I'm having a supply which is 100 volt is equals to 0.5 I1 plus a 0.5 I2 plus a 35 volts. So I need to do what? To group the like terms together, which is to be 100 minus what? Minus 35 is equals to 0.5 I1 plus 0.5 I2. So now, what is going to happen is, I need to find the difference between 100 and 35, which is 100 minus 35, which is what? Which is 65 volts. And 65 is equals to 0.5 I1 plus 0.5 I2. So I will name this as what? As the first equation. I will name this as what? As the first equation. For the second equation, what I will do is, as they said, the second equation is supposed to be B, C, D, E, F. I will follow the instruction by saying that I will consider the loop B, C, D, E, back to B, which is, what is going to happen is, always I'll start from the supply, which is the positive side there. I will have what? I will have a 35 is equals to what? Is equals to 0.5 I2 plus, what is going to happen is, the current there is I1 minus I2, which means it will be what? It will be a 2 into I1 minus I2. So now I'll say that I'm having 35 is equals to 0.5 I2 plus, I need to break out these brackets there, which is what? Which is 2 I1 minus 2 I2. So from the previous loop that we did there, we've been said that we need to what? To group the like terms together. So now, let's look where is the like terms. I'm having what? I'm having the I2 and I2. So now what is going to happen there is, I will say that I'm having a 2 I1 and 0.5 minus 2. What is going to be there? I will have what? I will have a minus 1.5 I2. That it will be the part of what? Of my equation, because I've been said that 0.5 minus 2, which is 1.5. And that is going to be what? I'm going to call it this as what? As the equation 2. Now I'm having equation 1 and equation 2. I'm having equation 1 and equation 2. But the question says that we need to calculate the current. But now, in equation 1 and equation 2, I'm still having what? Both variables, yeah, I1 and I2. And one variable must die. How are you going to eliminate one variable there? I need to balance my equation. How are you going to balance the equation? Let's go through the natural numbers. Natural numbers starting from what? From 1 up to 9. The others are just repeated itself. Now, if I'm saying that, I'll look through to two equations there to say that the equation, usually the equation that are having a less values, on your variables is the one that you're going to do what? You're going to balance that. So now in equation 1, I'm having 0.5 in I1, 0.5 in I2. In equation 2, I'm having what? 2 for I1 and 1.5 in I2. It means that the I2 is having a higher value of what? Of the variable. I must go through to what? To balance the equation 1 there. So what I'm going to do is, I'm saying that I'll choose the numbers from the natural numbers. If I'm taking 1, multiply 1 by 0.5, I'm still going to get 1. If I'm multiplying 2 by 0.5, I'm going to get what? I'm going to get 1. If I'm multiplying 3 by 0.5, I'm going to get what? I'm going to get a 1.5. But now when I check, 1.5 is still there. In where? In equation 2. So it means that to balance the equation 1 must be multiplied by what? By 3. So I will say that equation 1 must be multiplied by what? By 3. So I'm going to multiply the entire equation. Which equation? Equation 1. Which is what? I will say 3 into 65 is equals to 0.5 I1 plus 0.5 I2. So now, I will calculate, say, 3 multiplied by 65. What will be? I will have what? I will have 195. And say, a 3 multiplied by 0.5. I will find the value of what? The value of 1.5 I1. And I will say that a 0.5 multiplied by 3 still going to be what? A 1.5 I2. Now, if you check this, is another equation. That equation is changed automatically. So, which means I will say that I'm having this is what? Equation 3. Now, if you check the equation 2 and equation 3 through to the I2, both are having I 1.5 I2, 1.5 I2. It means that these two equations are what? Are balanced. It's going to be easier to do what? To eliminate the variable I2. To eliminate the variable I2, what is going to happen is, through to the I2, we check the sign in between. I'm having negative and a positive. In order to eliminate these two equations, I'm going to do what? I'm going to say that equation 2 and add by equation 3. So now I'm going to do what? To add the entire equation, both equation 2 and equation 3. So which is the equation 2 there, I'm having what? I'm having 35. And equation 3, I'm having what? 195. And it will give me what? A 230. And the equation 2 and the variable I1, I'm having what? I'm having 2I1. And the variable the equation 3, I'm having what? 1.5. So which means I will say that I'm having 2 plus 1.5. I'll find the value of what? The value of 3.5 I1. So now I'll say minus 1.5 I2 plus 1.5. That is going to give me what? It's going to give me a 0. It means that this variable I2 now is eliminated. So now, what I will say that I'm having what? A 230 is equals to 3.5 I1. And in order to make the I1 and the substitute the formula, I will divide both sides by what? By 3.5. What I did on this side, I must also apply on this other side, which is what? 3.5. So now the I1, it will be what? It will be a 230 divided by a 3.5. Now let's find the answer there. What will be the answer of our I1? I will say that I'm having a 230 divided by 3.5. And what will be the answer then? The answer I will have what? As the I1, I will have 65.714 ampere. That is the value of the current of the I1. So I find the value of the I1. Now I'm supposed to go to find the value of the I2 because of the variable that I'm having only two variables, which is the I1 and the I2. I'm having the I1 and the I2. Now I'm having the value of what? Of the I1. So what is going to happen is, you are going to select one of the origin equation, or one of the original equation. The third one is not an original because of we're using that to balance the equation. So the original equation is what? Is equation 1 and equation 2. We can choose either equation 1 or equation 2. So now, let me just say for this one, we'll say that substitute the I1, which is equals to 65.714 ampere in equation 1. Let me just say we've been selected what? An equation 1 there. So which is equation 1 is what? Equation 1 of us, we've been given 65 is equals to 0.5 I1 plus 0.5 I2. And we are saying that we're going to substitute I1 through to equation 1. So now I will say that a 65 is equals to 0.5. Where is I1? I'll put what? I'll put my 65.714. So which is it will be into 65.714 plus 0.5 I2. That it will be what? It will be my substitution. Now, let's multiply 0.5 by 65.714. 0.5 multiply by 65.714 and see what is going to be the value there. The value of that is going to be what? It's going to be 32.857 plus 0.5 I2. So now, what is going to happen is, I still need to do what? To group the like terms together there. Which is what? Which is 65 minus 32.857, which is equals to 0.5 I2. So now, I need to get the difference between 65 and minus 32.857, which is, I'll say, 65 minus 32.857, and the answer there, I'm still going to find what? I'm still going to find the value of 32.143, which is I'm still having 0.5 I2. So now I need the I2. So which means what I'm supposed to do is I'm supposed to divide both by what? By a 0.5 in order to make the I2 as the subject of the formula there. So which is the 0.5 and 0.5, they will subtract each other, and then therefore the I2, it will be what? It will be a 32.143 divided by what? 0.5, and what will be the answer there? The answer, it will be 64.286 ampere. So now I find the value of the I1 and the I2. Now the current that is going to pass through to our load resistance there, it's going to be the difference of these two. So now, which means I can say that the I of the load is going to be what? The I1 minus the I2. Because of I do have the value of the I1, and again I do have what? The value of the I2. It will be just a matter of doing what? Making a substitution. Whereby the I1 is what I'm having? What I'm having? 65.714 minus the I2 must be what? Must be 64.286. And let's just see what is going to happen with the value of what? With the value of the I load. I will say that I'm having 65.714 minus 64.286 equals to, and what will be the value that is going to pass through to our load there? It's going to be 1.428 amperes. So now it means that we do get the value of what? The value of I1 minus I2 as less than all those two values. What is the reason? The reason is these two batteries are supplying the R load. So what I can try to say, that I'm having battery A and battery B. These two batteries are doing what? Are supplying the value of the R load. So now, Even if you can try to check the value of the voltage drop, this value of the voltage drop, if you calculate it, it's going to be lesser than these two value of the voltages due to the current that I'm having. So we can try to prove that, to say that the VD, the voltage drop across this, to say that when we're comparing with these two, is it going to be lesser compared to these two or not? So it will be the VD is equals to the I load multiplied by the R load. The I load is what? I'm having 1.428, and then the R load, I've been given that as what? I've been given that as 2. And then what will be the value of that voltage drop across the load resistance there? It will be what? It will be 1.428 multiplied by 2. It will give me what? It will give me the value of 2.856 volts. So now it shows that obviously the value, that the load that we're going to supply there is having a less value of the voltage. So now, before I wrap up, is if we find that the value of the voltage drop here is higher than one of the supply there, it means that the current of that is going to be negative. But we don't have a negative current. It means that what is happening? One of the battery there is discharging. If we've been connected to the two batteries that are not having the same values there, and the other one is having the less value compared to the value of the voltage drop, it means that that battery, the current that is going to pass through that particular battery there, it's going to be what? It's going to be negative. It means that is what? Is discharging. For any further information, you can contact us on a website, www.ehlanzenicollege.co.za, or you can contact us on a Facebook, which is say Ehlanzeni TVET College, or on the Twitter, which is say Ehlanzeni TVET, and for your YouTube, Ehlanzeni TVET College. And this, it will be the end of our lesson. Thank you.